Thanks. If you need me, I'll be in. Yeah.
Yay! Hi, Stefan. It'd be much less entertaining from this morning. I do love the community biz. I think we're gonna. Afternoon, everyone. Welcome to DNS Privacy. I promise this will be, if you were in DNS Op this morning, this will be a much calmer sort of meeting. So just to give you a heads up. Mr. Bellis, if you can grab the door at some point, I would love you a lot for it. Oh, so that would be, Suzanne's got it, thank you. So, welcome, I'm Tim, that's Brian. Terry's our great area director. Dan York is JavaScribing, and now he's fully caffeinated and he's in great shape. And Chris Wood, raise your hand, Mr. Chris. I know you're here, you're gonna take minutes. I don't see you, Chris. Oh, okay, so if Chris doesn't, we don't see Chris, then we'll probably, some help on the minutes may be good. But it should be a fairly light agenda. You all know the note well. This is pretty good. This is actually the updated text. I made sure I got the updated text in there, so somebody approved of it. There are blue sheets passing around. Please fill them in. We like to see what's going on. They gave us a big room, so we didn't, yeah. Very quick update. We got a couple current documents, but basically there's some new documents coming up that we're going to kick about. But the big thing is we have some new milestones from the last working group meeting. They did a recharter. Brian and Terry worked on some, it actually went much simpler than I expected. But we have three new milestones about develop requirements for adding confidentiality to be recursive authoritative. Of course, that's why we're all here. And we're looking at sort of doing potential solutions for DNS exchanges involving authoritative servers. And we want to do some more, collect some more operational, basically, performance data. I think the more performance data we collect, the better we can sort of prove to people this is a very viable technology, which I really am pretty strongly thinking of that. Oh, the other thing that I was going to make is DNS service discovery. David Schnazi's here. He's currently chairing by himself. So if you're interested in getting involved and chairing a working group, it's a light working group. Got a great area director. Doesn't get a lot of mileage. Good work. And you should talk to Terry Manderson. He'll raise his hand. That's the only thing you have to do today is raise your hand. We promised him a simple, pleasant meeting. So, and I have to produce now. So.
You promised.
I did promise. I did promise.
While we're on the topic, David Skenazy, while we're on the topic of DNSSD, I'd like to take 30 seconds for a shameless plug. One of the things that we're working on in DNSSD right now is privacy. So right now, if you look at the multicast traffic on this network, you can find basically everyone's name, which is not great. We want to fix that problem, and I know there are a lot of people in the room who have a passing interest in privacy. So please come to our session Thursday morning or join us on the mailing list, comment on the documents. We have a lot of people with experience in DNS, not as much in privacy. Please come and help us out.
That's a great point, actually. So thank you, David. The only current document and update is padding policy, and we found the author. He was hiding or something. So Alex, he's not here, but he showed up and he's like, okay, he's fixing the discusses right now with the IESG, and I think we'll be ready to sort of move this forward into, IETF last call. So it just took us a while. He tends to disappear for periods of time. So quick agenda, Brian's he's got some RIPE Atlas probe data. Sarah's going to talk about the BCP document as well as the 7626 biz. So we're going to combine those all in this one happy-go-lucky session. I think Nick or Annie is going to speak. Nick's going to talk about Oblivious DNS. We always love these sort of wacky things. In the spirit of DKG, I always say. So this is like a 4DKG sort of a meeting. And then we're going to sort of lead a discussion on recursive to authority. I'm going to give it to Brian to lead most of that because I basically ranted and raved all morning and I think people are tired of listening to me. So I'll let Brian have that kind of fun. So I think we'll turn it over to Brian to talk about if there's any other agenda stuff you want, if you want to talk about the milestones, anything, just say your piece now or just come yell at us, or yell at me. So.
All right, I'm just going to make this real quick because this is pretty rudimentary right now. First thing I want to do is say that all the right folks that work on the Atlas probes, come find me because I actually appreciate the fact that they got the DNS over TLS capabilities built into their probes rather quickly. So what I did is I actually took one of my summer interns and gave her something to do. And that was to help this working group out without her knowing it. Essentially what we did is we took advantage of the new capabilities in the RIPE Atlas probes, and we started doing measurements of the uptake of DNS over TLS. Basically what Catherine did was she took 1,000 probes at a time and started cranking out measurements of what was going on. And essentially we just looked at the number of responses based on how many DNS servers were configured within the probes themselves. So we weren't trying to do anything specific with changing DNS configurations or anything like that. We were just using the DNS servers that the probes are attached to. So we managed to get in about almost 41,000 queries. We hit 3,600 IPv4 DNS servers. We did hit a couple of IPv6 DNS servers, but I haven't had a chance to go through that data yet. We had to get rid of a lot of the responses because they were all from private IP addresses, which weren't going to tell us anything. And so we essentially got 61 servers to respond over TLS, which is a paltry 1.67% of the servers that we talked to. However, after having some conversations with Oliver and Martin from Cloudflare and the folks at RIPE, we found out that a lot of the bad responses that we were getting either to the 1111 or the 1001 servers is basically due to a crypto mismatch. So what I'm going to do is we're going to actually go back and make sure that the probes that we're using are using the upgraded OpenSSL library. So those numbers should go up by a fair amount once we rerun the results. Going forward, the whole purpose for me setting this up was to actually get a regular set of statistics on the uptake. And so we're going to automate all of the data collection. I have to go through all the fun public release things at a university to actually get a web page put up, and then figure out ways to visualize this so it is actually useful and something that people can reference. The other thing I've been thinking about is whether or not to look at a non-Atlas based approach to doing some of these measurements, mainly to hit a wider range of resolvers, but that's still TBD. And that's all I got. Questions, comments?
Sarah Dickinson, thanks for doing this work. This is great. I'm wondering, could you get any visibility of whether or not port 853 was blocked for these measurements?
So the error results that came back actually give us some indication of what might be going on. Mm-hmm. We did get a fair number of connection refused, and other ones were just connection timeouts. But we haven't generated the statistics yet. But that's one of the things I want to do as I'm automating the results is to measure not only what the success rate looks like, but also what the potential causes of the failure were. Because
it might be worth considering doing. I don't know whether you can do this with the RIPE Atlas probes, but doing it over 443 as well, because some servers do offer it on 443. Yeah, so I'll have to take a look at the API, because right now I think it's just defaulted to using 853. DK?
Hi, this is Daniel Kahn-Gilmore. Thanks for doing this. I would love to see this continue to happen. So this is great. I'm wondering if you could clarify a couple of the details. Can you go back a slide? Yeah. Next one forward, I guess. That one, yeah. So you've measured 61 DNS servers. How many of the RIPE probes did that? Like the percentage is based on number of servers identified overall, or? Oh, do you see what I'm saying? If there could be like 100 probes who all talk to one server.
Right. No. So the roughly 41,000 queries came out of about 25,000 different probes, or 2,500 different probes.
Okay.
And if you go and look at the RIPE Atlas statistics, they have roughly like 10,500 probes.
Right.
So because we're actually asking for groups of 1,000 probes, we're just randomly getting assigned probes. One of the things that we want to do in order to address the SSL mismatch is to specify which classes of probes we want to use. And so some of these numbers are going to change, mainly because my understanding is that the difference between the V3 probes, which have the SSL mismatch, and the V4 probes, some of those are topologically different. Okay. So we might see different results. But part of what I want to be able to do with this visualization part is see how much of the address space we're actually measuring, and that will give us a better visibility as to where these DNS servers might actually be.
Okay. And then my second question is about whether you're also using this to look at reachability of known DNS server TLS resolvers, or whether you're just looking at the resolvers that happen to be configured on the probes themselves.
So this is where the RIPE Atlas is interesting, because it doesn't actually do a resolution. It just touches that port, makes sure that it gets a response and can associate with it,
right,
and then goes away.
So but there's still an opportunity there to do this reachability test towards, say, Quad 9 or 1.1.1.1, where we know that port 853 should be open. Mm-hmm. And that a TLS handshake should be possible, but I'm just clarifying that this testing that you've done here doesn't do that kind of reachability test from the RIPE Atlas probes.
Well, you get an indication of reachability, because you either get a successful connection or you get back an error state, right?
Right.
So part of the reason why I know that we have the problem with that 1.67 number is because when I go and look at the raw statistics, I find 1111 in there a lot with an error state.
I see. So I guess one of the things that I'm suggesting is that maybe for future tests, to not only test connectivity to the configured DNS resolver, but also to test connectivity to known active functional or ostensibly functional DNS server TLS resolvers.
Yeah, okay, yeah, so
Because one interesting thing is the network going to allow port 853 through,
yep.
right?
No, that's a good point. Yep.
So, or intercept it and do TLS man in the middle for taking advantage of opportunistic mode or whatever. Like, it'd be nice to get those kinds of measurements too. So this is great work. Thank you.
Yeah. So, any other questions? Great, thank you.
Sarah, I believe. Oh, yes. You're more than welcome to do whatever you wish.
So I'm going to talk about two drafts, and I'll start with the 7766 biz, because it makes more sense to try and explain why we did this. So this was published 3 years ago now, and it was actually the first document that came out of Dprive. And the intention was that this described the privacy issues that users of the DNS have. And it was supposed to be an analysis of the present situation, not prescribing any solutions. So this document came out before we had any of the Dprive standards and before DOE was developed. So it is entirely focused on clear text DNS. And as we know, things have changed now. The main document that I've been working on is the best current practices. And the feedback we got after it was discussed here at the last meeting was that people would like to see that reframed in terms of threats and mitigations. So we started writing the new version, and what we realized was there was lots of threats around using encrypted protocols that weren't described anywhere. So I actually started describing those threats in the BCP document, and then thought, this is stupid, this isn't the place for them. The right thing to do is to go back to 7766 biz and update it for the present situation and put the threats in there. The idea being we'd then have two companion documents. We'd have an updated document describing privacy issues and threats, 7766 biz, and then all the mitigations are what we're describing in the best current practices. So the kind of things that we've added into the document are, we now mention that we have new standards and that there's some deployment of them. There's a ton of references, which were drafts and are now RFCs. We've added a new section about the potential for client identifiers in the DNS payload. There's some text in there that describes attacks on encrypted transports, and it's essentially generic text. It's about the problems associated with using TLS, for example. But I couldn't find a good source to point to describe those, so I've added it here. But so that's one thing that would be good to know if people think that section is useful. There's a section which compares doing DOE and DOT and the difference in what that exposes to the resolver. We talk about authentication of servers and what can go wrong with that. And we also talk about the potential blocking of encrypted services, forcing users back to clear text. So with this document, it would be good to know if people think this split approach is correct and that it's right to update this document. And if they do, feedback on anything else we should be putting in here now because things have changed. Shall I keep going and we'll just do one set of questions at the end unless anybody has anything?
Something outstanding which they
Okay, don't seem to. Okay, so.
Of course they do.
Just one, Nick Sullivan, Cloudflare. Just one question here. One thing I don't see listed here is traffic analysis of encrypted DOT, DOH.
I think we mentioned it in passing on the attacks on encrypted transports. I think it's in that section.
Okay, so it's in that section.
Yeah.
Thanks.
Okay, so now to the main document. We've updated the recommendations document for DNS privacy service operators. This is still a very early document. We've brought it here to get initial review. We're still not sure where the long-term home for this document will be. We've also presented it in the RIPE BCOP working group. So we're still churning this document over, trying to find its correct structure and form. And at the moment, this seems like the best forum to get feedback on it. So the document had two main goals. One was to try and pull together in a single place the considerations around operations, policy and security for servers, operators who are running servers that offer privacy services. The first version of the draft was solely focused on DOT, but we've started trying to include considerations of DOE in this one, but we need more work. But given that that's now through working group last call, it seemed appropriate to bring it into this document. And the other is we're trying to suggest a framework so that operators can produce statements that are nice and consistent and easy for users to compare. There are deployed services, so it does seem that this is needed. There are large-scale servers out there, and particularly with DOE, it looks like we're going to see more in the very near future. So we do think it's a relevant document. What I'll do is I'll briefly walk through the big changes we made since the last version in terms of the structure, and then hopefully get some feedback on it and decide if this group is still willing to carry on working on it. So in the first version, we had references to relevant documents kind of scattered all about the place. So what we've done is we've tried to draw them all together and put them in an appendix. So hopefully this will be a really useful reference section for people who want to get to grips with DNS privacy. We have significantly reframed the recommendations section, which is where we are trying to say what operators should actually do for their service. The request we got from the last presentation was very much, the first version was really quite prescriptive. It was set around a must, should, may structure. So what we've done in this case is we try to make it more contextualized by describing a specific threat and then what can be done to mitigate it by the operator. And we've also actually reused the approach from 7726 where we divide up the threats into three places. One is on the wire between the stub and the resolver, one is in the resolver, and then the other is upstream outside of the resolver. And we think that actually helps the structure a little bit. We had a very much a placeholder section earlier on data minimization, so we've expanded that. I'll talk about that later. And we've also had an attempt to compare the policies of 4 large operators. So again, in terms of the way we've reframed it, so each section now has a threat description. And then what we have is 3 categories of actions that operators can take. The first one is a direct mitigation. And we're saying that operators of servers that want to be minimally compliant with these best practices should do all the direct mitigations. If they want to be moderately compliant, they should do the optimizations that are recommended. And then there are some additional options which would make you maximally compliant. And some of those you might pay, for example, a performance cost to do. So that's why they're optional. One thing that we did come across writing this version is that we initially reused the term privacy enabling DNS server, lifted directly from 8310, which is the DNS over TLS usage profile. And that is restricted to saying that the server must do DOT. So we clearly need a new definition that adds in DOE. But again, I think we're now realizing we shouldn't just restrict it to DOT and DOE because QUIC could come along. So we probably need to actually develop a new phrase or a new way of talking about servers that offer one of a number of encrypted transports. And whether we should do that in this document or whether that should sit in the terminology biz is a question I raised on the mailing list. I'd be interested to know if people feel strongly one way or the other. So I'll quickly spin over in these few slides the content that we now have and how it's split up. So the on the wire section considers both the protocol options and the service that's offered by the resolver. So we talk about what transports can be used. We talk about the fact that operators should allow clients to authenticate, how they should do their certificate management, what protocol options they should use, like padding or session resumption, cookies, performance optimizations, things like that. And also the service availability and the fact that they should always offer the same services on encrypted and unencrypted services. So all that now sits in the on-the-wire section. At rest in the server, we look at both data handling and data minimization here. So again, based on some feedback, we split up the data management. So we now talk about transient data, so data that might be held only in memory for real-time monitoring. And we separate that out from logging, and then we separate that out from additional tracking and correlation that can be done. We talk about access to this data, and there's a placeholder for cache snooping as well, because we think that's a worthwhile thing to discuss here. For the data minimization, what we tried to do in this version of the draft is actually, ideally we would have liked to come up with some recommendations or a small subset of here are the best tools to do this. What we actually did is we did a survey of what's out there, and we largely focused on the handling of the IP address because it's not the only, but it is the primary vector for identification in DNS data. We started delving into what it actually means to talk about anonymizing or pseudonymizing data, and it turns out it's actually quite a grey area, the specific difference between those two things. And we tried to look at what is being done out there, and we found that there's no real clear definitive answer. There's various techniques, they have various security properties, and actually it might depend on your use case in terms of whether you want things like reversibility, or you have to have something that's truly anonymized. So that's all in an appendix. We hope that will mature over time as there's some consensus as to which of these techniques are suitable for DNS, but we may well go back and look at the use cases in more detail there. We also look at the data sent upstream, and we bundled two things together here. One is what happens on the wire upstream, what goes from the recursive to the authoritatives, and also data sharing, because we consider both of those similar in that it's data leaving the actual server. So here we specify things like QNAM minimization, what to do with the DNS client subnet, running a local route. We talk about options to do traffic obfuscation, and then a bit more about data sharing. And while that overlaps a lot with data at rest, we did think there were some separate specific concerns here. And if you look in the document, I meant to put this in my slide, we've now tried to create some easy to read tables of this is what all the operators do in terms of both their policy and their practice. So we took 4 big operators. Cloudflare and Quad9 offer encrypted transport, or rather they do DOT and DOE. Google doesn't do any encrypted transport yet, and OpenDNS does DNS crypt, which is one of the reasons we wanted to include them there. So what we tried to do was take the proposed framework for the document and apply that to their privacy policies. Because what you end up trying to do in assessing what these operators do is you end up reading pages and pages and pages of text and privacy policies, and you have to wade through it all and extract the details of what services they're offering, what little knobs and bells and whistles that they have. So we tried to condense that into some tables. And it was kind of an exercise in saying, well, if we could get operators to adopt the framework, how much easier would it make the choice for users to just at a glance compare between the operators to see what they do? I will say that I am not sure that the tables are complete or correct, so we would appreciate feedback from operators to see if we got there, because we're not lawyers and we just had to wade through all this text. But it did actually feel quite useful, and some interesting things dropped out of it. So those are all the changes that we've made. I'd be really interested to hear, actually here's a good question, who's read the latest version of the draft? Okay, cool. So of the people that have, I'd be interested to know if they think the new structure works and it addresses the comments that we got on the earlier versions. It would be good to know if they think the new content is appropriate. And as I said before, does the working group want to continue? Are they willing to put time into reviewing this? So that's, yep.
Barry Green of Akamai. First recommendation is we need to break this into 2 documents. If the goal is to have not a BCP, because at 1% deployment, you don't have best common practices for operator. right? So you break down it first into an informational RFC that says, here's your guidelines for how to deploy, right? So you focus on the deployment, the resiliency. It's missing a big section of resiliency.
On what, sorry?
Resiliency.
Right, okay.
I'm in New Zealand, I lose my 2 fiber optic cables. How does DNS work? But Jeff's on the other side of the straits, right? Different country. He's not New Zealand. So that's a section. I mean, that's a thought through you have to go through with it. Break it into 2 documents where you say, how do you handle the data? That needs to bring in, actually talk to operators who are actually managing the data, the mobile operators, and also the whole security community who has a huge key dependency, because the thought process within the operator community around Dprive is on the data handling part. They're going like, yay, we have a way to go after and figure out what's going on in the IoT because I have certificates, and certificates give me identity, and identity gives me a way to, I can start seeing inside the home with a NAT behind the NAT and start identifying all this, violated, broken into equipment. So there's always this push-pull between the privacy and how do you build a resilient internet. And building a resilient internet is to be able to identify the infected parties and to get a remediation criteria around that. So if you try to keep both of them together, you'll never have people say, I'm BCP compliant.
Okay.
Right? If you break them apart, then you'll have BCP compliant. You can take informational operational deployment and then say, I'm compliant. This specification, I'm doing my BCPs of deploying it in a proper way. And then you break that apart from how do I manage the data separately. If you keep the 2 of them together, you're never going to have any operator say, I'm compliant to this.
Okay, I understand that. Thanks.
Paul Hoffman. First, let me reply to that. I think you can keep it in one document and have the BCP section or not. Just the more documents we have, the more likely that someone will read a subset of them. But what I got up to ask, I have a question for you. What is your time frame on this? And the reason I'm asking is, Doe's not finished. Mm-hmm. So I know you're probably not trying to get done before Doe. But one of the things that we've been finding in the last few months is people go, ooh, this Doe thing looks cool. I will do X. And our brains go, So I'm not sure we can really give sufficient warnings to some of them about how to do it right unless we've sort of seen them all. So, and I'm not saying wait forever. What were you thinking on that?
So with this, we think very much it's going to be a living document, actually, which was why in some senses we were hesitant to bring it here, mm-hmm. because this assumes some kind of process. So I actually think we will see huge changes over the next year. I really do. So I don't think this is going to go quickly. What I would like is a relatively stabilized version that we can build on to emerge quite soon in terms of the structure and the approach to writing the BCP.
A stabilized draft or a stabilized RFC?
Draft.
Okay,
I
great.
think.
Okay, good. Okay, so we're in agreement that you might let this, like even if you're sort of done-ish, you might still give it some time to see if other people come up with weird things that we need to talk about.
Yeah, I think that'd be the nature of it, because we're just seeing so much change.
Great.
And even the other approach is that we decide this is useful, we try and get the structure right, and we agree that the first thing we'll do is biz it. Mm-hmm. But I don't know how useful that is. I think we may as well just take our time and see how things go.
Great. I like that idea.
Okay.
Dan York. Paul, do you think we're going to have weird things to talk about in the DNS working group? But Sarah, I like this draft. I think it's a good kind of document to have. I personally think it's great to have it here because it is building on the other efforts and work that have been primarily coming out of Dprive. Yes, Doe as well, but I think coming out of here's there. My feedback was actually that I felt when I read the document that the last part about the privacy or DPPS parts, that almost felt to me like it should be its own separate thing, because it kind of felt you have all of this implementation guidelines and best practices and things, and then kind of at the end it's like here's a page on, oh, by the way, here's how to write a policy statement. Yep. And I also think that that's probably maybe a different audience than the people reading the main document. Or they may farm that out to somebody else to say, you know, hey, we need one of these for our website or for our other thing. Can you go look at this document to do it? So I would almost see it as a separate document that would define that, because I also think that may be something that you could probably write in a way that would be more stable. Like you could define what makes a good DPPPS type of thing and have that there. And then while the other guidance may change over time, that may be fairly static.
Right, okay.
Anyway,
So,
I throw it out.
yeah.
I think it's a good draft. I think we should do it here. That would be my only comment.
Yeah. I mean, again, when we wrote it, we thought about splitting them up, but we thought they were just so tightly coupled that actually, at least for the initial stages, keep them in the same document rather than constantly, you know, referencing back and forth. But as it matures, that might be a sensible split.
This is Daniel Kahn-Gilmore, ACLU. So I really appreciate the work on this document, and I just want to disagree with the folks who are encouraging you to split out the data management parts. I think privacy, as we're starting to look at it, is a really difficult and interconnected problem. And I'm not saying that this document needs to solve all of it right now, but if we're talking about giving people guidance for how to operate a privacy-preserving service, and we don't talk about how they manage the data that they're sitting on top of, we really haven't done the job. And I say this acknowledging that this kind of work is, I think, unusual within the IETF to encourage people to, like, how do you run your server? What do you do with the data once your server has it? We haven't really done a lot of that. But I think it's worth doing. And I think if we're really taking privacy seriously, we need to incorporate that, and the tight coupling, it works well. So thank you.
And I think one of the things we're discovering as we do this work is that privacy means different things to different people. You know, if you ask, and also there's lots of different perspectives on it. So it's almost like we maybe need to define what we mean by privacy. I mean, there's lots of places that's happening. There's lots of work on that, but maybe some of the confusion here is that we're not contextualizing it in a way that we could be doing. So maybe that's what we need to think about.
Lorenzo Colletti, I'm going to go ahead and disagree with you on that. On the purely pragmatic perspective that, or rather, if we want to publish a document, then publishing a document with all these basically data retention guidelines is going to be an incredibly hard job, because we're going to have to talk to people with skill sets that aren't found in this room.
Yep.
And we're going to have to, you know, and the law may change under us and all sorts of things. So I feel that if we want to publish something, then there's stuff that we can publish, like do anonymization, or like here's how you run a reliable service, or like don't shoot yourself in the foot with pins, right? Things like that. I think those are sort of very tactical. I'm not saying we shouldn't work on the other work at all. But I'm saying that, you know, the realities of the necessity for rough consensus mean that you don't actually publish for as long as like 2 people in this room disagree with you. And it can be a long slog. So in that sense, if you split it up into 2, now if you don't ever want to publish, that's fine. But the downside of that is that we don't ever have a best practice, and we don't ever have a actual RFC that recommends what to do. So 2 ways about it. I mean, I like to have stuff published, so I would sort of generally be on the side of splitting. And, you know, DKG is going to tell me you can't split it because the operations directly feed into privacy, right? I can hear it already, and that's true. But maybe we can somehow abstract that out. I don't know.
All right, so I'm going to cut the mic lines here. We'll finish this out real quick. Everybody who's up can sit.
I have something to say too, yeah.
John Reed, Akamai. One specific question. I like how you broke it down into different levels of compliance, specifically around EDNS 0, unusual client subnet within EDNS 0. That was listed. One of the minimal mitigations was for recursives to honor a scope of /0 and to not pass on ECS. I noticed a lot of the work so far seems to focus on the large public cloud providers. What's the plan? What incentives are there for ISPs to work with this, for whom not using ECS has maybe significant costs associated with what link the traffic goes out when working with CDNs and things like that.
Sorry, could you just repeat the last bit?
Sorry, so the actual question is, given how much of this is focused on public cloud providers, are there plans to incentivize ISPs running their recursives for their customers to onboard with this, particularly around ECS, where not using ECS may cause actual costs for them versus in terms of traffic links?
So I think there'll be some things that incentivize the ISPs to actually start offering the encrypted transports. And I think that will be because if they don't, all their traffic will disappear to the big cloud providers, which then means they need to look at this. And I think it does make sense that they could offer two services. One, I mean, this is what Quad 9 do. They have one service where you can choose to have ECS go upstream because you don't want to pay the performance and benefit cost, and then another service where you don't. So I can kind of imagine ISPs offering graded services. Now, which one they make their default, of course, is the interesting question. But I think there's sort of interesting times ahead with ECS anyway, outside of the scope of these offering encrypted transports at the resolver. I think general resolvers have questions to answer about their use of it. So
Right.
It goes beyond the scope of this a little bit.
Fair enough, yeah.
But I take your point that there are several things in here which are optimized for privacy, not for performance.
Right.
So I think it becomes being able to be seen on a level playing field as a big cloud provider who does tick all the boxes, so that you're a good choice for users. And that was the idea of the framework, that it would be easy to compare. But that's a challenge.
Yeah, just looking at it from a US-centric point of view of ISPs consolidating and, people not having choices in ISPs, and
Right.
they could just easily decide, well, you don't get to send port 53 out of our network at all.
Okay.
So,
yeah.
So I just wanted to address the question, Allison Mankin, the question of the data management portions and the things that are a little bit more speculative. So we are spinning up an IETF group. Sarah is one of the co-chairs of that, which is for privacy enhancing technologies. And it might be a reasonable suggestion for that group to take on a data anonymization document, which could be referenced, and then whichever document finishes first can have more material. But that is one of the reasons I thought we needed that research group, is because we don't really know how to do some of the pressing requirements that have come up as we work on DNS privacy.
I agree, and it was we realized it was a particular challenge writing this version of the document, because we literally couldn't find references to tell us what's the standard. How do people do this kind of anonymization? So
Some of it's research, yeah.
Yeah, we literally had to do some research. So I think that's a great idea to take the work to that group. Thanks.
Just quickly, this is Daniel Kahn-Gilmore. So I heard a couple people say something about the data retention stuff being too unstable because the laws would change out from under this. We are not writing a legal document here, right? We're writing a document about how to preserve the privacy of the users of a DNS privacy provided service. And so when I was advocating that we keep these things together, we should be keeping them together by thinking about the nature of privacy and how it's affected by the data that's being gathered. And that's irrespective of the different laws that we may or may not be subject to. Some of my best friends are lawyers, but this is not a legal document. And so, and also it's a best current practice. And yes, things will change. And so we should be fine with revising the best current practice. And there's a lot of wiggle room available in the minimal compliance, moderate compliance, maximal compliance framework that Sarah has spec'd out, so that if somebody is, upset because they only meet minimal compliance in one area, I think that can still fall under rough consensus.
All right, so Tim and I were both encouraged by the fact that there were a fair number of people who raised their hands saying that they had read this document. So unless somebody objects very vocally in the next 2.5 seconds, we'll do a working group last call on a mailing list.
Call for adoption.
Or call for adoption.
That was fast.
Larry, you promised us.
Right. Yeah, we'll publish this tomorrow.
I just sent the email, so.
There you go. So for those who have opinions on it, respond to the email, please.
Yeah.
Thanks, sir.
Thank you. Also, what about the biz document? Do we feel it's ready for an adoption, or do you want more review on it?
It would be nice to get an initial review on it, I think,
Okay.
before we did that. Yeah, thanks.
Yeah, so we would encourage people to read the biz document as well and provide comments to the authors and on the mailing list. All right, Nick? Your turn.
I want to make sure I get the right one. Hang on a second, Nick. I want to make sure I got the update. It's PDF.
Oh, because I have animations.
Oh, you have animations. We broke. The IETF broken.
Should I project from mine? Can I use time?
You can probably. Okay. Do you have one of these from computers? Okay. Okay. Of course, the privacy guy is using PowerPoint with fancy animations, so we've got to hang on a second and do a. And just slide them. Over. And PowerPoint. It is the PowerPoint. The Googles. Oh, the clicker thingy here. Yep. Clicker thingy is yours. Yes, it will.
So I think the only detail is that when you do that, I'm not sure if Meet Echo can they put the slides remotely? Oh, beautiful. There we go. Never mind.
There it is.
Technology solved.
Ready? Go. Thanks for the time. This is a new draft. The first author, Annie Edmondson, is not here. Paul Schmidt is in the back of the room. Allison, of course, is here. We're here to solicit feedback on the draft, which I hope many of you have read. I will spend some time summarizing the design and the current state of affairs for you, and then we'll open it up for some feedback. In considering this work, we were motivated by discussions about DNS privacy that had come up in various contexts about who gets to see the queries and the IP addresses of those queriers at the recursive resolver. And there's a lot of discussion about who gets to run the recursive, and a lot of the nature of the discussion we've been seeing is, if you simply change your recursive resolver from your ISP to some other third party, then all is well. Your ISP won't be able to see your DNS queries and link them to your client stub IP address. Of course, that shifts the trust from your ISP, but it shifts it to a third party who still basically sees both the IP address of the query and the domain names. They're visible. They're visible even, of course, if we're using DNS over TLS, because TLS only encrypts the transport. So that third party recursive is still going to be able to couple the domain name with the IP address. So I'm not going to get into all the work that we and others have done about the risks of that. And this is the DNS privacy working group, so I think you all know it. So I'll skip that. But this is the problem that we were motivated to think about, which was, could we remove that liability entirely? In other words, rather than moving the trust from one party to another, could we make it so that nobody could couple the query with the IP address? So that's basically the motivation for the design of Oblivious DNS.
It's different from some of the other things that have been discussed on the mailing list. We can talk about those and others towards the end as there's time. I'm going to talk to you today about the design that's described in the draft. As I mentioned, the goal is very simple. You've got a query and a response, and you've got the IP address that issued that query and the response. And the goal of the protocol is to make sure that no single party sees both of those. That's it. Okay, so what's the high-level idea of how the protocol works? The stub is going to obfuscate the query before it goes to the local recursive. It's going to also do something to the query to generate a referral. In other words, it's basically going to append a suffix for a second-level domain that generates the referral to a special authoritative. That authoritative is going to be one that can decipher that query. So that authoritative can see the DNS query, but not the IP address of the requesting client. Asterisk there. I'm going to come back to eDNS client subnet later on, but that's basically, in the general case, the properties here. So the recursive sees the IP address of the original query, obviously, but not the queue name. The authoritative, the ODNS authoritative, sees the query, the queue name, and the response, but doesn't know the IP address that initiated the query. That's it. Okay, so let me just talk a little bit about mechanics. This is a familiar picture. We all know this picture. There's basically one additional hop that we add to this path. Okay, that ODNS authoritative does two things. Basically, it does everything that I just told you about, right? It also acts as a recursive. Okay, you may have questions about performance. I'm coming to that. Okay, so there's a key. I'm going to tell you about how that key gets distributed in a minute. That stub basically encrypts the original queue name under that key, shoves that ciphertext in the queue name. There's some great magic that we owe to Paul Schmidt to getting this to actually fit in the queue name. Details to come on that. But that's basically what gets passed to the recursive resolver. By the way, another thing in this picture, please don't take it literally, and I apologize for the colors and the animation. Academics do that sometimes. Sorry about that. The other thing is .odns is for the purpose of illustration. What that actually will be or should be is still under consideration and open to discussion. And Allison may want to say something about that. So that's for the purposes of illustration. Okay. That, of course, generates the referral. That ODNS authoritative has that key. It's a session key, actually, for this query. Then the rest of the picture looks similar, right? It's the standard recursive resolution that we're familiar with. The answer basically then gets sent back, encrypted under that session key. Okay. Where does this stuff go? Currently, we are, as I mentioned, we're putting the encrypted name in the queue name itself. We've tried some other things. I think pretty much most of the people in this room know why the other things we've tried wouldn't work. We had to discover that. Okay. Okay. How does the key get distributed? This is the way we do it right now. So basically, how does the client learn about a key for an ODNS authoritative under which it can later send a session key? The session key, by the way, is I should mention. Thanks, Willem, for pointing this out. It's actually passed through in the queue name as well, not in the additional section. But in order to basically generate a session key and send it, client first has to know a public key of an authoritative ODNS under which it can encrypt that session key. So it sends some special query because by our design expectation, these authoritatives will be anycasted, right? The process by which this discovery happens will naturally lead the client to a nearby recursive and a nearby ODNS authoritative if the deployment is appropriately replicated in Anycast. That's the idea. The answer comes back as a self-certifying name. In other words, the name is the public key, and that's basically what's used for the client to generate future session keys, right? So this is just the key for the ODNS, public key for the ODNS server under which the client generates future session keys for the queries. Okay, I made that point already. There are a bunch of changes, both at the stub and the authoritative, that we've made in a prototype implementation. We brought it to the hackathon. We got a lot of good suggestions about both the design and implementation. I'm coming to that. Thanks for the hackathon, by the way. Great event. It was very helpful for us. Here's a summary of basically the changes that are required. Obviously, the stub has to do a bunch of things like generate a session key, encrypt it, as I just showed, send it back to the authoritative, augment the domain in this funny way, right? So we basically got to take the original queue name and mangle it in the way that I described. There's a, as I mentioned, Willem kindly pointed this out 30 seconds before I got up here. The session key is appended, it's actually put in the queue name, not in the additional section. Okay. The authoritative basically has to do the appropriate decryptions and forward a recursive. It basically acts as a recursive. There's some implications for caching. We can get into that in the discussion as well. Okay, so where are we? There's a prototype implementation in Go. If you are interested in that, talk to us. We'll share it. Paul is also here. Be happy to. He did a lot of that implementation and be probably, I'm sure, happy to talk to you about it. We were fortunate to have the involvement and interaction and feedback from the NLNet Labs team at the hackathon to both have a look at this and figure out how we might get it into a real implementation. One implementation detail that we discovered, so as I mentioned, if you try shoving these keys and encrypted names into various records, you all know, but you will also discover if you try it that they don't often make it all the way through. Recursives, for example, don't handle the additional section in many cases because of the hop-by-hop semantics. I guess it's probably worth reading the standards sometimes before you try these things. But yes, you'll be happy to know that it is in many cases implemented as spec'd. So we had to look for other places to put the keys and the encrypted queue names. This is where we basically use some special elliptic curve magic that Paul, I think, can be happy to talk to you more about to get the keys down to a size where we could actually fit them in the queue name. As well as the names, once we encrypt, obviously they also have to fit in that queue name as well. We're not putting them elsewhere. When we do that, there's some names obviously that are too long. Once we basically do that and then append, to generate the referral, some of them are too long. We tried this on a Kata web cache trace, and this works for most of the domain names we saw in that trace. There are failure scenarios. The failure scenario, I think, which is not described in the draft, but we envision is that, okay, if in this particular implementation, what we do is you just don't get ODNS if your encrypted queue name doesn't fit, but that's certainly open for discussion. Another thing that came up at the hackathon on this was that currently we're basically just using a regular query type, but another possible alternative would be to take the entire queue name the entire query and the response in the reverse direction, basically just shove everything into TXT. right? And that has some advantages. One is you don't have to deal with this problem, but the other advantage is that the Q-type also would be encrypted in that case, right? So we're not encrypting Q-type here, and folks at the hackathon observed that the Q-type could actually leak information, and that might be another way to go. There is a performance evaluation. I was advised not to bore you with graphs, but I'll give you a sort of short takeaway, which is that the crypto operations are, so we did some micro benchmarks and macro benchmarks. The micro being like, how much latency is this going to add to a single lookup? And the macro being like, okay, if you load web pages, like how long is this going to add to web page load time? Okay, so crypto operations are actually pretty fast. Like most of the time is in the decrypt at the ODNS authoritative. But when you add everything up, we're basically talking about a millisecond, and that's basically with our, you know, academic prototype implementation. Presumably, this could get a bit better. So there's 1 millisecond there. The other additional latency cost that you pay beyond just a regular DNS lookup is the network latency between your recursive and your ODNS authoritative. So there's one additional hop that I showed you in that picture. That's basically going to be additional network latency. If both of those are anycasts, if both of those are co-located, then things look really good. If there are like 2 ODNS authoritative servers, as there are right now, then your mileage will literally vary depending on how far your recursive is from that authoritative. So it's certainly to the advantage, to the performance advantage here to replicate these and put them as close to the local recursive as possible. There are a bunch of practical considerations. I've mentioned some of these. I'll raise them. I think this is probably the forum where we're probably most interested in talking about some of these. One is that I mentioned at the beginning, part of what we're doing assumes that the local recursive is going to, when it basically performs the query, that the authoritative is going to see the IP address of the recursive. And if it's passing on client IP addresses through EDNS0 client subnet, then that kind of defeats the whole point of what we're trying to do. So that's something to think about. Our current systems implementation solution to that is to not use recursives that that send EDNS client subnet. There are a bunch. I'm going to show that to you in the next slide, but this is standards group, so we should talk about that. I've talked about all the OPT additional record considerations already. The short version is that obviously they don't work because of the hop by hop semantics, so we had to do other stuff. There is one thing that came up in the hackathon that the NLNet Lab folks pointed out, which is that currently we're using base 64 encoding for the encrypted domain and the key. The drawback to that is, we can't use OX20 encoding. We need those bits. That's obviously important. So an alternative that we were discussing there was using base 64 encoding or a 7-bit option. And I talked about the Q-type being the clear already. That's something else, another design alternative we could consider. Okay, so right now, I won't spend any time on this since we're talking about standards, not implementation. But there are, we basically, in order to get this to work right now, we need basically no EDNS0 client subnet and no 0x20. There are a lot of open recursives that actually satisfy that right now. We can't use the others. Okay, that's it. In summary, what we are trying to do is better protect privacy by decoupling the client's IP addresses, from the queries that they're issuing, making sure that no single recursive resolver sees both of those. We've done an implementation and a performance evaluation that sort of show that this could work. Not only could, it actually does work. And I think important note is that it's completely compatible with existing internet protocols. This can pretty much operate in very restrictive environments. We make no assumptions about transport requirements, no assumptions about support for TCP or TLS or any of the like. If those things exist, this will work as well, but we don't need to make those assumptions. So in terms of thinking about this as an alternative or a complement, I would say this is basically a complement. It can work with many of the other things that this group is already talking about. It's complementary to everything I've read in the current group activities. Thank you.
We got a quick 5 minutes for questions, so.
Mine up quick.
Hi, this is DKG. Thank you for this. I like your framing of it as complementary to existing approaches. And I'm wondering how your threat model deals with the concern, your proposal earlier of the two, the recursive and the ODNS server being co-located.
Yeah, that's a very good question. I figured you might ask that. And actually this I think we also discussed a little bit at the hackathon, is like how that might get cooked into the draft, because obviously you don't want the same party operating those at the same time. You like performance sort of suggests that they should be close together. So what to do about that? I mean, there are certainly data centers where that is possible. But yeah, I think there are administrative and other questions. I mean, certainly firing both of them up on AWS cloud services might not be the first thing to do. Yeah.
Are you next or am I next?
Tobias Wiewich, TU Delft.
Yes.
Mike.
Yeah, just a little bit louder. I can't hear you either.
Okay, Tobias Wiewich, TU Delft, and I would shoot two questions. A, how are you handling DNSSEC?
This is basically it's orthogonal and complementary to DNSSEC.
No, is it compatible?
Sorry?
Is it compatible?
Yes.
Okay. And the other question is, don't we get as an ISP basically a known plaintext oracle? Because if somebody queries for an A name, I don't know, but then I do get a connection in my NetFlow to an IPv4 address. I can basically infer the name that was originally queried.
Okay. If I understood and heard the question correctly, the question was about the threat model, and basically, okay, your ISP may not see the DNS lookup, but it's going to see the subsequent TCP connection to some IP address because it's capturing NetFlow, et cetera.
And may thereby be enabled for further attacks on the crypto.
Okay, so is there, what further attacks? Okay, yeah, there's, we're running low on time. Short answer to the first part anyway is, sure. I mean, the ISP can see NetFlow and things like that, then absolutely they can try to make inferences from that. Shared hosting and other things mitigate that somewhat, not entirely. But this is the DNS privacy working group. So, I mean, certainly there are other concerns. We can try to deal with those in other contexts, but I don't think this makes those attacks more possible, because the ISP isn't going to see the thing that it first typically relies on.
Well, let's give some time for the others.
Yeah.
Hi, Dr. Scorla. Interesting idea. I mean, I'm trying to think about how to put this together in my head, and it seems like the observation here really is that the recursive resolvers, the open recursives, are a free IP anonymizer. Like, that seems like the actual observation here. Am I understand that correctly? Then everything else, like if you had open TLS Connect proxies, you could just do that perfectly well, right?
Sounds about right. Yeah.
Okay, yeah. So I guess I've skimmed the draft. I have some crypto type questions. I was a little surprised to see you didn't describe how the ODNS key is secured. I assume that's an oversight, and you mean to say it's DNSSEC signed?
Oh, right. That's a good point. Yeah. We should talk about
Otherwise,
that.
presume we have some serious problems, right? Secondly, why are you using ECIES as opposed to just straight to Hellman key exchange, since you could claim presumably 16 octets that way, if not more?
Paul, do you want to make a comment on that?
Oh no, I can get you back like 16 octets.
Okay.
Just send like a Diffie-Hellman key directly in, and then HKDF it out and use AES-GCM to protect the data, like, and you just reclaim some bytes.
This is why we're here. I mean,
Okay.
I won't speak for Paul, but like, you know, I think I could say we're generally crypto.
Okay,
but
yeah, I think
amateurs,
I think I reclaim some data for you.
Perfect. Thank you.
Unfortunately, you have to give it back because you don't have a Mac, so.
Okay, we should follow up. Thank you.
Barry Green, Akamai.
Hi.
Say, it's a interesting piece of technology. If I put my operator hat on, I got increased complexity, increased cost, more fragility into the system as I design mobile networks and broadband networks and things like that. And a huge pressure right now, like when I put on my 5G hat in the working groups in 5G, where you're getting a 2 to 5 millisecond connect time to the device, whether it's a VR device and others, and at 20 millisecond, boom, I'm functional, got first page load. And here you're adding things to do, I'm still, and now I put my security hat on, what security problem are we trying to solve here? Because I'm still scratching my head, what is the threat vectors I'm trying to respond to?
Yeah, it's you. In fact, I'll reframe it. It's a privacy problem, not a security problem in this case. To your point about performance, there is a cost. I will point out one thing in that regard, is this is domain by domain granularity, right? So if you have performance considerations for particular objects or services or web pages, then you don't have to use this, right? You can serve objects through this for only the domain names that you'd like to. Now it wouldn't be you, but the users would like to potentially not have you see. There is a point that I will agree with you on and sort of tee up for the group, which is that obviously DNS client subnet is useful to folks like
just
yourself.
So on a DNS client subnet with it, and I know people wanted to say, oh, he's Akamai. I'm not speaking about Akamai. I'm talking about what's going on in the mobile environment as we deploy 4G plus and 5G, right? The dynamics there, is independent with it, and there's a DNS resolution speed criteria of what's going on with this that I think we have a big disconnect between what's happening here in IETF world and what's going on with this that everybody's using, right? So this is just, throw off the Akamai, just take note. I go to one community and I hear one thing. I go to this community, I hear different, and we're in two different camps.
Yeah.
And this is impacting us. Right, so this is something that I think we need to be mindful of.
All right, next question.
Yeah, Chris Wood, thanks for bringing this.
Hi, thanks.
To Dprive, it's very interesting. Two quick questions. I apologize if I missed the first one regards to the threat model. Are you at all concerned that this authoritative ODNS server effectively turns into a central point of failure for all of your DNS queries? Unlike if you were to compromise COM or any other authoritative route, you could still get to others, presumably, but if you happen to shut off the ODNS resolver, everything's dead. It's
a concern. So, I mean, I think basically we can think about resilience in terms of, it doesn't have to be one name or authoritative. Sure. So the standard DNS resilience techniques could work here, but it's actually a real concern. Like you said, I mean, something that I really hadn't thought too deeply about it, but is important is we think about blocking and censorship and other things like that. If there was just one, it would be pretty easy. But that's true of DNS as well. But I think we are subject to that as well.
Yes. Second question, if I may.
Yeah, absolutely. Yeah.
Can you comment on how this impacts the caches of the recursive resolvers? I mean, effectively everything that's going through there is basically garbage, and they can't cache it.
Yeah. So you basically the caching benefits basically move from the recursive resolver to the ODNS authoritative because that's your new recursive essentially. That initial recursive still has per client caching, but you're right, it totally breaks shared caching for all the clients. So that's another reason beyond the latency hop why you'd want to basically have that thing everywhere.
The comment by Ecker was, why does per client caching work? Can you comment?
Well, actually, it only works if you don't rotate the session keys. That blob is basically a blob, right? I mean, that name can be cached because it's basically blob dot, something that the recursive understands. If you rotate your session keys, you lose that too. Yeah.
Do we actually think, are there any operators of recursive resolvers who think that per client clashes today would work?
I mean, anyone? No. I'm done. I was just posing the question to the group effectively, but.
I'll make it quick. I'm Jim Chatia. This is a very interesting idea, and I hope to see a more specific implementable spec in the next version, because I found the current version basically only describes the idea, and many implementation details are missing. So I hope the next version will cover it. And
we'll work on that. Thank you.
One related point is that as long as you depend on opt-RR, EDNS, I think you basically cannot expect the recursive server to forward it because EDNS is essentially a hop-by-hop protocol. So I guess this is not about the implementation issue, but should be part of the protocol itself.
I'm not quite sure I follow the question. I heard that, I sort of understand that you have a question about EDNS client subnet and.
Yeah, in that case, it's a part of the protocol. So EDNS itself cannot require a recursive server to forward that. So if you want to use, okay, anyway, I think I don't have time. So I'll send comments.
Yeah, there's definitely trade-off there.
Hi, Witold Kręcicki, ISC. I have two questions. First one, are there any measures against profiling the client? We don't have his IP address, but we have full set of his queries because the session key is, well,
you're saying like, can the recursive, even though it's seeing like encrypted?
No, the ODNS authoritative sees the complete set of client queries.
Yeah.
So are there any measures against, using it? And if I might follow with second question.
Yeah.
Do you have any idea for fallback if the queue name is too long encrypted? Because I can imagine a rogue server sending a very long CNAME just to see just to force the client to fall back to non-ODNS query, and
Yeah. In the case of fallback, I mean, that's part of the reason why we're here talking to this group is, I mean, we certainly have our own implementation idea, which is basically just to fall back to regular DNS, but that's arguably maybe not, you got to do that with care, right? Because if somebody expects that they're going to have a certain level of privacy and we just silently turn it into a regular DNS query, then that's probably not so good. Your other question, was about timing attacks and
profiling.
And profiling. Yeah, I think that's possible. It's also not unique to this protocol or implementation. So, yeah.
Sorry, we sort of killed the mic line unless it's a really fast comment.
Okay. Well, I may be missing something, but you said you plan to use Anycast. Fine. So let's say your node changed because of routing, how the key was shared, how another node would get the key, or you have to rekey your session.
The session keys can be, I mean, so the session keys can be right now we're doing it per query. So yeah, if you had if routing changed your Anycast destination in the middle of a query and response, then that would be a problem, just like any other Anycasted DNS response. But obviously whatever's coming back would either not come back or we need to rekey.
Yeah, so the client have to do that. Okay, and I mean, one more thing, like you may still want to change the key because otherwise you have complete query history for the client. There is no key lifetime consideration. I mean, okay, it's a draft proposal, understand, but you probably
That's a good point. We don't say anything about that, so we might want to, I think we probably do want to.
Okay.
We want to consider
Make a draft. Okay.
Yeah. That's also, I think, open for consideration and discussion because, obviously we don't know what the best thing to do is there. So that's something where the group can help us.
Okay. Thanks.
Thanks. Thank you.
So we were going to do a stage 2 discussion, but that seems to have gone off the rails. So I think Brian and I were just talking, it seems like we'll probably end up doing like an interim meeting where we just basically break down the topics that we have, because we had two sets of, what Paul was going to talk about, the user world, I think it was Benno was going to talk about the implementer side of things. So we have some slides that of course, they're uploaded. So, because I think we'll need a good 30 to 60 minutes. I guess an interim would actually give us a good hour to sort of hash some stuff out. Anybody feel like they're sorely opposed to that? And I think we'd rather do that than wait till Bangkok. So anybody wants to speak up and sort of bash on that, just let us know. But let's see, I would say probably mid-August, unless we think all of Europe's going to be on a holiday then. But we should shoot for something like an interim, like mid to end of August, basically.
Paul, so could we start talking about it on the list?
Yes.
Yeah. Oh, yeah.
Okay, before the, I mean.
Oh, yes, before the interim, we would start.
Before the interim, so I'm not clear then, like, it's not just giving presentations.
But it's
there
getting
seemed to be a lot of interest in it. Can we, you know?
We want to move this forward.
Well, the only reason I'm asking is because you would, you know, you guys had limited what you wanted the talks about, you know, no solutionizing and stuff. Can you give us some guidelines for how we can do it on the list before the interim?
How about if we do that in the next day or so? Will that please you? Okay. What's that? We'll give them some guidelines the next day or so. Yeah.
The question I have is as Tim mentioned, we had Paul that was going to talk from a user perspective. We had Benno who's going to talk from implementer's perspective. I think we want to try and get someone who runs authoritative servers to also think about what the kind of requirements would look like. And I think in all fairness, we need somebody who is a root server operator as well. So if you're interested in kind of framing those use cases or requirements from one of those perspectives, run Benno, run. Then please let Tim and I know. Go ahead.
Yes, Benno Overeinder. Well, boldly also included some of operator perspectives in my slide. So operators, please have a look at it. It's for the root and for the TLDs, alternative deployment models to cover increased costs of TLS connections.
Okay,
Please have a look at the slides. Might also help for the discussions on the mailing list.
And I'd be glad to speak from an operator's point of view of just second level domains, but I tend to get sort of worked up about stuff like that. So
yeah, but you don't count.
Yeah, I don't.
But you have to call consensus.
Okay. Yeah, that's right. He said I promised him a pleasant meeting. So
right. Okay. So Tim and I will send something out to the list before the end of the week, so you can chew on it on whatever airplane flight you're going to be on, and we'll get the discussion going on the mailing list, and we'll let that kind of guide how we want to schedule any kind of interim meeting. So with that, does anybody have any final comments, questions?
Great. Then thank you. Thank you all.
Thank you.
Yep. No, it wasn't. And I wanted, I should have. Sometimes, especially like we had this problem with EKG one where he had a great. Thank you. Blue sheets. Blue sheets. The other ones sort of floating around. You're awesome. So, Ms. Wendy, there we go. Thank you. It's like you read my mind.